Hello everybody. We have a special guest today, Martin Milata of Red Hat, who's going to show us his recent contributions to plugins family in regard to ABRT integrations. If you're watching us online, please use Q&A button in the YouTube feed to raise your questions. If you're watching us offline, join us on our IRC channel or mailing list to send your questions. Over to you, Martin.
All right, so hello, and let me briefly introduce ABRT if you've never heard of it. It stands for Automatic Bug Reporting Tool, and it's a program that watches your system for events such as binary program segmentation faults or uncaught Python exceptions. And if it detects something like that, then it saves information that is relevant to this crash and allows you to report this crash somewhere, such as to our bug tracker. However, most people don't want to report these bugs to our bug tracker because it usually takes some time and they need to provide additional information. So we also provide the option to send so-called micro reports, which are small reports that should contain no private data, and in Fedora we collect them on our ABRT server, which you can find on retrace.fedoraproject.org. And these micro reports do not contain all the information needed to fix the bug usually, but they are useful for creating statistics of what is crashing the most, and and sometimes it contains enough information for fixing the bug successfully. And what this Foreman plugin allows you is that you can send those micro reports to Foreman and see an overview of crashes that happen on the hosts that are managed by our Foreman instance. So here's an ugly diagram that shows what happens when you send a micro report to Foreman. In the normal workflow without Foreman, the U-report is sent from the managed host here directly to the ABRT server. And with the plugin, it is first sent to the smart proxy, and here it is saved to the hard drive because we don't want to spam Foreman with thousands of reports in case an application starts crashing on every one of your hosts every, say, minute. So these reports are stored on the smart proxy, and every half an hour they are aggregated. Reports that are considered to come from the same crash are aggregated into one, and they are forwarded to Foreman, where you can view them in the web interface, and eventually, if you want, you can forward them to an actual ABRT server. And the server can sometimes provide some kind of response. It can, for example, send you a link to a page that describes a workaround for the bug, or say link to the bug tracker with more information about the bug corresponding to the micro report. Right, so let me briefly say what is needed for installation and configuration of these plugins. There are two plugins. You need a plugin for Smart Proxy, and you need plugin for Foreman. So both of these plugins are available in Foreman YAM repositories. They need Foreman 1.6 or later, and the Foreman plugin does not need any configuration, actually. The Smart Proxy setup is a little bit involved. You have to install the plugin and then edit the configuration file. Where you have to set the Foreman URL, which is URL of the Foreman instance, and this configuration item is not currently set by the installer. So the proxy needs to know where to forward the ureports. Right, and also you need to enable the plugin if it's not enabled yet. So you have to configure you have to edit the configuration file of the ABRT plugin and make sure that it's enabled. There's also a couple of more options, but the plugin should work with the default configuration, and the options are documented here and in the documentation. Right. Then you also need to configure the hosts that are managed by Foreman and that you want to send the micro reports to the proxy. We currently support Fedora 19 or newer, and Red Hat Enterprise Linux 7, and perhaps version 6 in the future. So you need to make sure you have ABRT installed. Assuming you don't want any graphical utilities, you simply need to install the ABRT-CLI package. Ooh. Well, never mind. And you need to make sure daemon is running. Sorry. And the ABRT-CCPP service is running. Need to configure the client, send the micro reports to the proxy instead of the main ABRT server it's configured to. So you need to set the URL here, and you also need to make sure that the client uses Puppet certificates to authenticate itself to the ABRT server, which is now our smart proxy. There's also another step needed. You need to import the Puppet certificates, Puppet certification authority certificate to the set of system certificate authorities, so that when reporting the client trusts the proxy. This is described in the documentation as well. Also, usually the bug reports are reported manually, but you can enable automatic reporting of the crashes by running the ABRT right. So we should be pretty much up right now. So I can show you what happens when a crash of a program occurs on the managed system. We have nice set of utilities in Fedora and Apple that do nothing else but crash. So I'll run one here. So it did a segmentation fault. And after a couple of seconds, we should receive the report on the smart proxy. And we can check this by listing the directory where the reports are stored, which is varspool Foreman proxy ABRT. And we see that there's a file. So these files are aggregated every half an hour and forwarded to the Foreman. And we don't want to wait that long, so there's also the possibility. Yeah, the program that forwards the reports, it is run from cron. So you can either edit the time period to make it shorter, or you can simply run the program manually. It's called Smart Proxy ABRT send. Right. Do you have to run it under the Foreman proxy user or root? So the report should be available in the Foreman web interface. The plugin adds a new item in the monitor menu, which is titled bug reports. And here we see that some time ago we received the bug report. If you click on the time, you can see a little bit of details. There's a short message which comes from ABRT and which says what happened, time when it was first reported. First means in case of there's multiple repeated crashes when the first happened, and something called duplication hash, which is hash of the report used for the aggregation. So when two reports have the same hash, they are reported only once. All right, so here we can see that something bad happened, and the only interesting thing we can do with it is to forward the report to an actual ABRT server. So we can click this button and the server sends us some response. It can tell us that it already saw this problem. It has some server hash associated to it, and the server can also send some additional information such as links to locations where the problem was reported, such as to the ABRT server itself, or for example, Bugzilla bug tracker. And it can provide some, say, solutions to the problem, like link to the package that probably fixes the problem, or a page that describes a workaround to this. Yeah, the server that we can forward this report to can be configured, so you can either use the server that is provided by Fedora, or you can run one yourself. It's open source, so if it's useful to you, you can set up your own instance. You can do client authentication to the server. Right. Other thing that this plugin does is that it adds this bug reports tab to the host view. Oh, it's ugly. Where you can view all crashes for the host you have open. And it also adds this graph on the dashboard where you can see a number of crashes in last 14 days. So here you can see that there were 2 crashes today and nothing before it. And I guess this is all I wanted to say. So if you have any questions, feel free to ask.
Okay, thanks. We don't have any Q&A questions, but I have a few, or at least one. When you showed the report in Foreman, I haven't seen any stack trace or back trace. Is when a C program crashes, or even Python program crashes, is it possible to see the back trace in the report?
Currently, no. The problem is that every type of the crash, such as binary crashes or Python crashes or kernel oopsies, have a slightly different format of these stack traces. So we would have to write separate rendering code for each format, and this is currently not done. So to answer your question, it's currently not possible to see the stack trace.
But I assume that the report will be held on the client machine, so you can go to the vars pool and extract the information.
Yeah, you're right. All the information captured from the crash stays on the computer where it happened. So in the usual ABRT directory, you should be able to find the stack trace.
Another question. I've learned that micro reports are kind of feature of RHEL or of ABRT, and it's missing in RHEL 6. What does micro report stands for, and how is this different from the traditional, like if I say this right, traditional like ABRT report?
Well, the aim of the traditional report is to provide as much information to the developer to help fixing the problem, and that means you usually have to download debugging information in order to resolve function names in C crashes, or either download the debugging information or send send the core dump to remote retracing server. So in the first case, when you download the debugging information, it can be pretty large, like several gigabytes. And in another case, when sending the core dump for remote retracing, you have to upload it. It also can be pretty large, and it can contain sensitive information. So I can imagine that you just don't want to give it to anyone. And you should also review all the information you are sending in the traditional report, because, as I mentioned, we might accidentally include some sensitive or private information from your system which you don't want to give to us. So the ABRT client makes you review all the information you are sending, and this needs to be done manually. The aim of the micro reports is to avoid these two issues. So no debugging information is downloaded, and if the names of the C functions are not available, then only addresses relative to the start of the binary are sent, which we can resolve to the function names on the server. And we only send a limited set of information which should not contain any sensitive information. We don't send any contents of any variables or something like that. It's pretty much just the stack trace and some additional data like installed packages and other information. So this should make it possible to send those reports automatically without long processing and without manual review. Did that answer your question?
Yeah, I understand. Thank you. Since there are no other questions, I'm going to wrap up. So both plugins are available right now as we speak. So download it, test it, please install, report bugs, and get back to us. And thank you, Martin, for your time, for showing us how this works. And we'll see you next week, next time. Goodbye.
Thank you and goodbye.